Hello and welcome back to the attic. I was asked to test some FETs to see if they're real or not. These are a 30N06, but not a regular 30N06. It's an RFP 30N06LE. And these have gate protection on them. So basically there's some Zeners that protect the gate. Oh, there goes my light. And so first thing you want to know is, do they match the on resistance in the specification? And the specification is, let's see, my grocery slip says 0.047 ohms. So I have a power supply. I got, you can see here, this is equivalent of 1.5 ohms about. Got your heat sink, and I got the FET. I'm only going to test one because, you know, if you solder on a FET lead, it makes it harder to put into a circuit board later. So one should give me a good idea. And I have a good feeling about these. So let's start the test. Now this is 2 amps going in. And so we'll measure right on the drain the source. You know, I was thinking I had a bad light here because I got it at a free bin at a garage sale, but it's doing this on my other light, so it's the 30 volt boost converter. And I have a half dozen of them, so I'll just replace that at some point. But anyway, we got 42.6. And if we had 1 amp going through, that'd be right in spec, because the spec is 0.047 ohms, but I have 2 amps going through. So this beats the spec by double. You know, it's only half that value. So this looks good. Like I say, 10 volts, a standard test, 10 volts. I got a 10 turn pot. You all should get 10 turn pots because you know, you don't have to do any calculations or anything. You can just dial up whatever voltage you want pretty accurately. But I got 2 amps going through there, and so it's 0.021 ohms. Pretty amazing. The next test you do is how many volts is there really? And this is supposed to be 60 volts. And so I really like this little device. These are like $18, and I find it really very handy. A lot of this really cheap stuff is amazingly convenient. I mean, I don't have to set up any power supply or Zeners. Ow! Ooh, nasty. So I press this button, and we get 69 volts. And you know, the avalanche voltage of a FET is usually about 10 to 15% above what the FET is rated at. So, you know, we're at about 12%. I did a whole bunch of them. You know, they when I tested them, it was 68 to 47. You know, it'll change a little bit depending upon temperature. But, you know, that's close within spec. Now the other thing, I mean, I never thought much of these. I got one just because they were cheap. But this is one of these all-purpose inductance, capacitance, FET transistor tester. And darn, these are awfully convenient. I got to get something in a better case though. And so we turn this on. And you can see it's 1.48 nanofarads. And, you know, we're within close on the spec on that. And it's 2.2 volts. So these all range from 2.2 to 2.6 volts. That's really important with a lot of low voltage micros because, you know, 3.3 volt micro, you don't have much. Now this is a 30 amp FET. You know, if you can only supply 2.8 volts going into the gate, I wouldn't put a lot of current through it, but you know, if you do 3 amps or 4 amps. I have one time delay, and they use two 40 amp FETs in parallel, and they rate that at 15 amps, you know, and that's the Chinese, so it's pretty good. But well, I really like these. Now, what's really important about this gate capacitance is this is what actually tells me if it's real or not, because a Jelly Bean 30N06 has about 810 picofarads of capacitance, but this one with the enhanced gate is almost double that. So when something new comes out, you know, everybody wants it, and there's a chance that people will take a standard FET and relabel it because the demand and the money is in, you know, anything new. But these fully meet their specifications, you know. If you follow the numbers, you know, and it'd be good to get in there and look at some of these specifications on the data sheet. You can learn a lot. So that's the video for today. Thanks for watching.